Open source has started to become a worry because attackers are starting to attack it. We've known about these attacks and supply chain attacks in general for decades, right? They go back to at least 1984, I think, when Ken Thompson published this amazing paper called Reflections on Trusting Trust. He pranked a bunch of his coworkers at Bell Labs by putting a backdoor into a compiler. That backdoor was so smart that it would insert backdoors into everything it compiled. His coworkers were very smart though, so they know how to disassemble these binaries and look. But his backdoor was so good that it also inserted a backdoor into all the disassembling tools, so it would hide the backdoors when his coworkers looked at it. So he really baffled everybody and kind of showed that unless you know the tools that built all of the tools that built the tools you built all the way down, then it's hard to build up trust in software at all.
Hello and welcome to Committing to Cloud Native, the podcast where we talk about the confluence of cloud native and open source. Very excited to introduce our guest today. Before I introduce him, I want to make sure we get to the other panelists on this episode. I am, of course, Richard Littauer, the man without the plan. And then we have Justin Dorfman, the man with the Dorf. Justin, how you doing?
I'm doing great. I'm really excited to talk to Dan.
Me too. Dan, as Justin just said, is our guest. This is Dan Lorenc. He is calling today from Austin, Texas. Dan is a staff software engineer and the lead for Google's open source security team. He looks very secure where he is. I can see lots of No, he's just a normal guy in a t-shirt. So don't be overwhelmed by how awesome his title is. Dan, how are you doing today?
I'm having a great day. Thanks for having me on.
Is it really hot in Austin right now? It's really hot everywhere else, so...
Yeah, it's pretty warm. It's not as hot as it can get here in the summer, so don't want to brag too much, but yeah, we're warm.
Pretty good. Now, you live in Austin, but you've been in the cloud space for 8 years. You tell us how you got where you are. You know, how did you get into open source and Google and cloud?
So I've been at Google for about 9 years now, in the cloud space for pretty much the entire time since before it was called cloud. My first job at Google was on the App Engine team when that was kind of the only product Google had in the cloud area. If you're not familiar with it, it was like a platform as a service product before any of those buzzwords existed. So cloud kind of popped up around it and around me as I was working kind of this developer tooling, developer experience area. I got more into open source, probably right around when Kubernetes and containers started to pick up. I started playing around with Docker pre 1.0. I remember all the old gory days there and got into the Kubernetes ecosystem right when that started to take off. So it's been a fun ride since.
So how do you end up being a lead for the open source security team? If you're first in a space, someone has to hire you or something, right? So like, how did that happen?
Yeah, so in the open source and the supply chain security area, it was a case of just kind of being really worried about it before anybody else was, I guess. And actually, yeah, it kind of connects back to how I got into open source. When I started at Google, I was doing some working on our cloud platform stuff, but from the inside. And Google's got a pretty different development process than a lot of other companies. Everything's in a big mono repo. You've probably heard some stories about that. When you step outside of that mono repo and start building things open source, all the tooling disappears. You're not using the same internal build systems and everything. And it was kind of scary at first. My first open source project was Minikube. I started that project, I don't remember how many years ago now, but that was kind of the standard way to get Kubernetes set up on a laptop. And I was building it, on my laptop, publishing this binary on GitHub just from my laptop that people were just taking and running as root on their computers all over the world. And it was kind of terrifying compared to, the internal stuff I was used to. You're making that face now, but that's still how most people are doing, development.
When you say people, how many people are we talking?
Most of them, and it's scary. And so, I started to worry about that. Looked around, not a lot of better options in open source. So I've been worried about supply chain security there for a while. Got really serious about it maybe 2 or 3 years ago when still it wasn't a big topic. Maybe about a year ago, other people started to worry. The attacks started to pick up. People started to get scared other than just me. I stopped looking like a crazy person with a sign by the side of a road saying the end is coming. And then, SolarWinds and some of the other big attacks happened earlier this year. And now all of a sudden you're saying, why haven't we cared about this for long?
Now you win. First they think you're crazy, and now you win.
Yeah, if you're crazy for long enough, eventually people will believe you. Is that the motto?
Let me just tell Richard something. So Richard, I reach out to Dan and I'm like, hey, I really want you on the podcast. Then he responds with, oh, here, talk to this person. No, I want you on the podcast because I looked at your background with Minikube and Skaffold and Sigstore. I was just blown away. I was like, I didn't realize you were involved with all of that. So the one thing that we've been seeing a lot, especially with security, is a safer curl URL pipe to bash. It's been a topic on Hacker News. It's always been a thing. So can you tell me and the rest of the world about SGET? Because I just learned about it.
The curl pipe to bash thing, it's been a meme on Hacker News forever. People love to complain about it. There isn't really a lot better you can do in certain circumstances. I think it's also kind of misunderstood too, some of the problems with it. It's not quite as bad as a lot of people think, but it is really bad in some other ways, I guess. And then I think there's some stuff we can do to improve it overall. Where do we start, I guess? The curl pipe to bash meme, if you're not meme, kind of pattern, if you're unfamiliar with it, is a way to install a piece of software. You go to a website and it says, here's a little script. This will install the software for you. Just hit this with curl and then execute it on your system and it will do some smart stuff and install our code. People love to do that as developers because it's pretty easy to set up. You set it up once, you can have a bash script that's pretty smart. You don't have to worry about bundling for all 37 different Linux distributions for Mac, getting into Homebrew and ports and the Mac App Store and Windows executables and all the different platforms and everything like that. You can kind of just write one bash script that exists. Problem, though, is that there's not as much security, or there's kind of different security constraints when you're installing software that way. At least now, for the most part, people are doing, curl of an HTTPS URL pipe to bash. That wasn't always the case, 4 or 5 years ago before Let's Encrypt took off. And so that was really one of the biggest problems. If you're doing that, then you don't even know what script you're getting, or if somebody's kind of man in the middle and modifying the script before it gets to it. But if you do have a script that's served from a pretty good website and there's SSL set up, curl pipe to bash isn't the worst thing in the world. What it is missing, though, is a lot of benefits that package managers can give you and a lot of the protections that these package managers provide to the developers, too, which is kind of one of the parts that's misconstrued a bit. Like when you apt-get install a piece of software in Debian, say curl, for example, you're not taking curl from the curl maintainer's repo. You're not getting it from github.com/curl. You're getting a fork of curl, where the Debian maintainers have forked curl and they have promised to apply security patches within a timely manner for a set period of time. That's just how Debian works. The trade-off there comes from, though, is that they're going to be applying patches and they're not going to be taking new features in. It's really just security patches for that time until there's a new Debian release. And then they will bump the version of curl to pick up all the new features and then apply patches again going forward. So there's really no option in the middle for people today. You either get something maintained by a group of maintainers or you take it directly from upstream. And if you get it directly from somebody upstream, then who knows how you're installing it and all that stuff. Upstream maintainers don't have signing keys. Tampering can happen even in the places they publish stuff. Some of the attacks that we've seen there, one of the big ones earlier this year is when Codecov's Bash installer got compromised. Are you both familiar with that one?
Our listeners may not be.
Yeah, exactly. Go more into it.
Codecov is a popular code coverage scanning, and they wanted to make it really easy to install this tool and scrape your code coverage metrics as part of CI, so you can track them over time. Just like Linux distributions, there's 100 different CI systems out there, and so they package this installer up in a bash script, basically. You would curl this bash script, it would install a little reporter in your CI system, and that's all you had to do. Is really one line. So an awesome developer experience, and it's used all over the world. Unfortunately, they had some credential leak happen, which can happen to anybody. It probably does happen to tons of people. And somebody found those credentials and used them to tamper with the script that was served to users, and nobody noticed for months. They did some of the best practices you were supposed to do, like publishing hashes for this script and telling people how to verify them, but nobody was doing that, basically. Easy way was too easy, and people didn't follow the instructions for how to do it correctly. So it took months before anybody noticed this script, which was supposed to be uploading code coverage, was actually stealing all the secrets in your CI system and exporting them to some IPs, and we still don't know exactly where they were going. So that was one case where the script was downloaded from the correct URL. They published hashes. People didn't check those hashes, and something in the middle got screwed up. So we thought, how could we make this a little bit easier? And one of the ideas is this new SGET tool, which I think you were just talking about, right, Justin?
Correct.
Yeah, so this is a tool we started as part of the Sigstore project to try to make the easy way to download stuff also the safe/secure way. So safe get or secure get or something like that is where the name came from. And the problem with Codecov that they ran into really is that if you're going to distribute those hashes for the file you're downloading, you have to put them somewhere. You can't put them right next to the binary or script you're distributing, because then whoever gets the credentials to change that script can just go and change those hashes. And so they put them somewhere else, which is the right thing to do. They put them back on the GitHub repo, but that also means nobody's going to go check them because it's something else you have to do. It's another URL you have to figure out and go learn. So the idea we came up with is to use OCI registries. If you're not familiar with the term OCI, it's the same thing as like a Docker registry. OCI is the name of the protocol that Docker and everybody standardized. Now, the cool thing about an OCI registry is that you get a SHA-256 built into the URL directly. So it's a content addressable API. When somebody uploads a script, you get a URL with the digest built right in. All of the tooling enforces that it's correct. All of the servers enforce that that's correct automatically. So if you put a script there rather than a random S3 bucket or GCS bucket or something like that, then it can't really be tampered with from the time you give somebody a link to that thing. So it makes the digest checking built in and automatic and easy.
It's like SRI and it's like IPFS, right? It's like basically the same, like content addressable. How many people have to share that link before that's not a vector, right? Because if I share a link just with you and then everyone on this podcast knows that it's me and you, then surely they could just come to our houses with hammers and then they have the link.
Yeah. So, you still have to get that link to people correctly the first time. And there's some other stuff you can do there. But yeah, so if you're handing people a link, you get that SHA built in, you can check it. The SGET tool will do that. And there's some other cool stuff the SGET tool can do, though, like, help you with digital signatures, which are also pretty hard to do and are a pain today. If you do want to sign your contents with, a physical key, it's got a bunch of YubiKeys here. They're little thumb drives. I guess people can't see the video. But yeah, if you don't have a YubiKey, they're little thumb drive size things you can plug into your computer. They can get some secret credentials on there that you can sign stuff with. And unless you lose that device, people can't really forge those signatures. So we've got integration for all of that built in too.
Do you think it's important that people sign their commits?
I do not think signing commits on GitHub, and there's some subtlety here, I do not think signing commits on GitHub actually adds a ton of value.
Why not?
I wrote a blog post a couple weeks ago about this. It's a similar issue to the one about publishing a digest, for the content you're going to download right next to that file. On GitHub, when you sign a commit, the way signatures work in general, you have a private key and a public key. You give everybody your public key, you sign stuff with the private one, and then they can check that signature against the public key. With GitHub, you just kind of log in with your password and you upload whatever public keys you want for your account.
Yeah.
And if you sign a commit correctly, GitHub gives you a little green badge. So if you're trying to protect against people compromising your password for your account by signing commits, it doesn't really do much because anybody that compromises your account can also just change the public key on there. And so you'll still get that green badge. So it's kind of protected by the same password that's protecting the account in the first place.
But that's the same logic as Google protecting my password, because anyone could just hack into Google and then my password isn't protected. So is that the argument you're making here?
The argument I'm making is that signing doesn't do much on top of the password, right? So if you're trusting the password, then signing, it's kind of a false sense of security, I guess. There are ways you can make it more secure and get yourself some value, but that really comes down to using something else to distribute that public key on top of just GitHub. You've got to come up with some other system. Like you could tweet it, you could post it on Keybase, you could do a lot of these things. But for the most part, people just look at that little green badge on GitHub and assume it's more secure when you get that little green icon saying it's verified, which is sort of the problematic aspect of it.
Yeah, that makes a lot of sense to me. One of the questions I have that comes right off of that is, we are on the Committing to Cloud Native podcast. So we're all about cloud native here. How do you deal with security with stuff in the cloud when like tweeting your private keys doesn't make a ton of sense and then you're depending upon Amazon's ability to keep those keys sacred? What do I do, basically?
Yeah, there are a couple aspects to that, I guess. I think one of the biggest concerns, at least that I have right now in cloud native security, is Docker images in general. They're huge. There's tons of stuff in there. And for the most part, it's impossible to figure out what's in them once there are techniques, you can start signing your images now. We've got a bunch of tooling in Sigstore to help with that. But even if you do that, you're just signing this big opaque blob for the most part that, you're losing visibility into. So if you do a Docker build, you might have a curl pipe to bash inside that Docker file and nobody will know by the time you hand them that Docker image. Yeah, there's a whole bunch of case studies that have been done. These things go stale. You build an image, it's immutable, which is great, but it's immutable, which means it never updates. And so you have to build a new one to update it. And so there's a whole bunch of problems that I think will be pretty easy to solve eventually once we start taking it seriously, but aren't quite solved yet. If you look in your Kubernetes cluster, there's going to be hundreds, thousands of images in a big one. And in each of those, you're probably going to find 20 or 30 vulnerabilities when you start running them through scanners, and they start to add up quickly.
But it's your job to take things seriously early. So you're already taking it seriously. So I know you already have a fix for this. What is it?
It's kind of another philosophical change people have to start to make in the way they build software. Going back to that Minikube example I talked about earlier, I was building these Minikube binaries on my laptop and handing them to people. Eventually, we graduated to building them in a build system, but that was just Jenkins sitting on a Mac Mini under my desk at the office, right? You wouldn't run production infrastructure on a bunch of Mac Minis sitting under people's desks, right? But for some reason, we're okay with building software on them and then putting that software right into our production environment.
Yeah.
I think the big shift we have to make, and we saw this with the SolarWinds attack in general, was that you need to start treating your build environment as seriously or more seriously than the production environment you're going to deploy into, right? You wouldn't go build a huge fence and then slap a cheap lock on the front of it, right? That doesn't really make any sense. But the build system really is the doorway into our production environment. So if that's not at least as secure as the environment that you're going to go put that stuff into, then it just becomes a natural attack point, and attackers are starting to figure that out.
So not to go into, vectors of attack for Google, but to totally go into vectors of attack for Google, you are the open source security lead. There's also probably a security lead, and there's also probably a physical security lead. Do you three all meet up in like a dark room with cigars and figure out like what to do and where to put locks?
We have a lot of security leads across Google, right? Google takes security pretty seriously. There are thousands of people that work on it. Open source has started to become a worry, like I said before, because attackers are starting to attack it. Right? Open source now is under attack. We've known about these attacks and supply chain attacks in general for decades, right? They go back to at least 1984, I think, when Ken Thompson published this amazing paper called Reflections on Trusting Trust. If you haven't read this or watched any videos about it, you should really look it up. It's amazing. He pranked a bunch of his coworkers at Bell Labs, basically, which is full of very smart people, by putting a backdoor into a compiler. And that backdoor was so smart that it would insert backdoors into everything it compiled. His coworkers were very smart, though, so they know how to disassemble these binaries and look. But his backdoor was so good that it also inserted a backdoor into all the disassembling tools, so it would hide the backdoors when his coworkers looked at it. So he really baffled everybody and kind of showed that unless you know the tools that built all of the tools that built the tools you built all the way down, then it's hard to build up trust in software at all. But for some reason, we forgot about it after the 80s until, the last couple of years. The best answer I've gotten to that one, I don't have a definitive answer, right? I haven't sat down all the attackers and asked them why they've only started inserting vulnerabilities into open source software in the last couple of years.
Dude, that sounds like you should do that. Why haven't you done that? Yeah. Come on.
Let's get them on the next episode of the podcast.
Deal.
The best answer I've gotten is that we finally gotten so good at locking down all the other ways, right? In the 80s, software security in general was terrible. You didn't need to go and hack a compiler to do these cool tricks. Even in the last decade, security's gotten so much better in general that these supply chain attacks and using open source as a supply chain vector haven't really become easier on their own. They've just become relatively easier because we're using password managers and two-factor auth and HTTPS and all of these other things that we should have been doing this whole time. But now that we are doing those, these supply chain attacks are becoming relatively easier, and they're also more insidious in a lot of ways.
After SolarWinds, it seems like all of a sudden your position is just like totally validated. With that said, we know some folks at the PSF who got that $300,000 grant for supply chain security. What was your role in that, if you had one, or how was it?
Yeah, the PSF has actually gotten a couple of grants lately. One came from Google. I think they got another one from Bloomberg. A bunch of organizations are starting to take this seriously and fund, this critical infrastructure. This one, yeah, I'm sure you've probably seen that SGET. I can't remember the number now, but it's, got this picture of all these crazy complex things built up and all modern digital infrastructure. And then it shows one person holding up one tiny corner of it. And it says, one maintainer maintaining this thanklessly in Nebraska by themselves for the last 20 years. And I think, the PSF runs some critical infrastructure to our industry, which is, the Python package index warehouse and all of that stuff. And I think, a lot of huge companies that take critical production dependencies on this don't realize how underfunded, understaffed a lot of these things are. And so we've been trying to find a lot of those across the industry that people are relying on without realizing it and, get them visibility and get them funding that they need to better maintain and secure and support this infrastructure. And those grants are also going to do some other cool stuff like, integrate vulnerability scanning into the Python tool chains and make it, easier to understand what your dependencies are across different requirement.txt files. I
got to say, I think probably the most prominent non-code contribution to open source in the past fiscal year is that XKCD graphic with the, with the Nebraska.
Yeah, all this stuff piled
up. Yeah, the Nebraska. Like, I'm seeing it in reports that are going to Congress. Like, it's out of this world. So we'll put it in the show notes, but it's just a powerful graphic.
I just keep wondering who it is. I mean, I know Dave Gandy lives in Kansas City. So Fawn Awesome is in Kansas City. That's the closest I can get to Nebraska. But who is a developer in Nebraska? There's got to be one. There's got to be one somewhere down the dependency chain. I want to find that person and thank him.
Reach out from Nebraska, whoever you are.
So supply chain checks are the equivalent of taking a couple of horses and a few pistols and hitting up a stagecoach as it goes between Bank 1 to Bank C across Nebraska back in the old days, right? That's like, let's hit it here. In open source, that kind of works by hitting the dependency tree. And dependencies are really complex things that are really easy to hack. Justin and I have interviewed Dominic Tarr before on our other podcast, Sustain, where we talk about these sort of issues a lot. And he was the owner of LeftPad, right? Which had a whole thing happen to it. And that was when we realized, oh crap, what's going on with our dependencies? Dan, what is Google doing to stop dependency nightmares, zombie dependencies, vectors hitting that area?
So open source is a critical piece of most software supply chains today. Nobody's running software without open source coming in at some point, right? And so that's why we're starting to see it attacked. A combination of how widely used it is. LeftPad was a huge wake-up call there. How many different dependencies show up in your transitive tree? Right, you might only install one in a node application, but then that installs 10 that each install 25, that each install another 30, and the combinatorics start to blow up. And so if you look at each one of those as a potential attack vector or an attack point, you start to get pretty scared. I don't remember the exact LeftPad story. I think it was just deleted, right? It wasn't actually attacked or something like that. It was deleted or untagged or yanked from NPM or something. Which is
someone asked Dominic Tarr to be the maintainer. He's like, yeah, I don't need to maintain this thing. I live in a sailboat. I'm done. And gave it to him, and then that person then deleted it, and then everyone's like, crap, all of our builds broke.
Right. Yeah, so it wasn't attacked. There was no malware inserted, no Bitcoin mining. It could have been much, much worse, but it was a big wake-up call to everybody that had something depending on that didn't know they were depending on that. And there have been some other scary studies showing that the transitive reach of some of these packages on NPM is huge. If you can get going to make up the stats somewhere. I think it was in a Sona type report. But if you can get the credentials for 10 people on NPM, then that's like 80% of all packages. The fan out ratio is pretty huge. So it's pretty scary that way. What Google's trying to do is just come up with some best practices, visibility, and insights around that so you can actually see how large your transitive dependency tree is. We can't just magically go and wave a wand and get every project to start reducing these things or cutting off their dependency tree or taking fewer dependencies or fixing all of the code. It's a cultural shift again, just like the rest of it. And so a lot of it is around showing the visibility, how important it is to know and not just blindly add things to your Go mod file or your package lock.json. So I think just because somebody wrote a library doesn't mean it's going to be better for you in the long run than finding a smaller one if it means a little bit more work for yourself. We're not the only ones in the industry working on this stuff. Dependabot at GitHub has been a huge help to people just to kind of automate and make that update process easier. And sending people smaller changes constantly is a way better tactic than only updating once a year and having to resolve dependency conflicts for the next 3 months. We're seeing huge projects like Kubernetes in the cloud native space too actually start to actively go and reduce their dependency tree, which is awesome to see.
So that's an interesting point about Kubernetes, right? Because in the cloud, what I'm often doing is having someone else run code that I don't actually see the dependencies. I just say, you go run this code. So can you even know as a cloud user what the dependencies actually are that you're able to be exploited by?
Not all of them, and that's a big part of it. If you're importing something directly, then maybe you can, look in its dependency file and see everything all the way down. But if you're just grabbing a binary or using a SaaS product or something over the service, then no, you can't. And that's pretty scary in a lot of cases. The Kubernetes one is also, there's kind of two sides to it, right? Kubernetes is this huge application with thousands of its own dependencies. People also import Kubernetes, right? Almost anything in the cloud native space reuses code from Kubernetes directly. And so by actively reducing their dependencies, right, Kubernetes is giving themselves a much better footprint and reducing their attack vector. But it also unblocks everybody up and down the dependency tree from starting to be able to reduce these things. And that's why this is so hard to kind of prevent and mitigate overall, right? You're kind of at the mercy of your downstream dependencies. And you might not have merge rights. No one with merge rights anymore. We see this a lot with the zombie dependencies we were talking about. A project could be super well maintained until it's not anymore, and somebody just moves on and deletes their GitHub or leaves it there without responding to email, that kind of thing. It's impossible to detect those because a really good stable project doesn't get a lot of work, which is awesome, and those are the type of things you should depend on because they're not breaking constantly. But that looks from the outside exactly like a project that has 35 CVs inside of it where the maintainer just stopped responding. So it's kind of hard to tease those apart in a lot of cases.
Yeah, I think maybe you bring a good point about dependency bot because I get pings on just my personal repos, like my website, for instance, and I update them because it's very simple to do that. And I think maybe another thing GitHub/Microsoft should be looking into preventing these zombie type repos and dependencies is once the project gets to a certain size, whether it's downloads or stars or whatever, is to have a successor or to convert that into an organization. I think that would probably be the next step to combat this whole, dependency hell security vulnerability. So I think some people at GitHub and Microsoft, you can make this happen.
Yeah, I haven't actually heard. I thought of it like 2 seconds before you said it, the way you led up that sentence. I'd never thought of the like converting it into an organization idea before. But I think
I forgot who said. I think it was Andrew from libraries.io who's suggested that, but I'm not sure. I just know they ran a study of most dependencies in the Ruby community. They just did Ruby because that's their world. Was 1 to 2 maintainers under a personal account.
Right.
So that's where they kind of got that idea. But sorry, I didn't mean to cut you off.
Yeah, that's a great idea. It's a subtle difference. And so if you never played around with GitHub that much, you might not understand the meaning there. But if a lot of these things start out under a personal GitHub repository, which means something like github.com/my-username/my-repo. And there's certain permissions you can do in a personal repo, like you can add other maintainers, but there's still only one admin, and it's the person whose name that's under. When you convert something to an organization, you usually give it a different name, but the overall pattern looks the same. So it's github.com/some organization, which could look like a username or not, and then that repo. And the organization can have multiple admins that are all kind of equal. And if one steps down, somebody else can kind of, they're also now an admin and can add other people and configure billing and do all of that cool stuff. So it's a really easy way to increase the bus factor, I guess, for a lot of these. I always forget the direction that one goes.
Having worked in a lot of organizations, I wish that were true. But most of the time, the lack of clarity in the actual organization itself can lead to that being more of a bus factor, not less. I know there are projects working on this, Clearly Defined, right? Clearly Defined is helped funded by Google, as well as AWS. And they're trying to basically build a giant database of all dependencies that are legal or not using SPDX licenses. I don't know if they're already doing stuff like security. They say they're on the website, but I forget whether or not they have, say, a list of this is this many maintainers or this is this many vulnerabilities. At some point, that would be a thing that's going to have to be done at scale, which just takes a lot of effort. I have kind of a different question, if you don't mind, which is, this is all horrifying. This is really scary. I'm scared, right? Everything is going to break. Everything probably broke yesterday. I just don't know it yet. How do you stay sane? Because it sounds like if everything is an order of magnitude as an issue, how do you decide what to work on next? And I know you've written a blog post called Procrastination-Driven Development, so this was a bit of a lead-on question. But I'm just curious, can you describe how that works in your brain?
Yeah, it's a great time to be in this field, right? There's so many problems. All of it is impactful. A lot of people get frustrated or turned away and they say, there's no magic bullet here, right? There's not one thing we can do that's going to fix it all. But that means there's 100 things that we have to go do, and we've got to do them all. And so there's plenty of room, plenty of opportunity for people to help out and get involved. I think one of the biggest areas, like you talked about, having data and visibility and knowing where all of these dependencies are coming from. That's kind of where I'm focusing now, most of my time at the Sigstore project, because I think that's kind of a prereq for a lot of the other analysis that we can start doing. The supply chains right now are, you have one, whether you know it or not. Your code is coming from somewhere, that code is coming from somewhere, but you probably can't write it down today. If I asked you, what are all of your dependencies? You might be able to write those down. When I say, what are all of those dependencies? You probably can't write those down, getting that transitive tree out there. There's another problem, though, which is where even if you can start to write those down, especially in the Docker and cloud native world, you might think this container came from that container, which was built in this system, which came from this GitHub repo. But none of that is verifiable today. All of that metadata is, it's just best effort. You're guessing that a Docker image was built from the repo that the person said they built it from and pushed it from. And so what we're trying to focus on there is verifiable supply chain metadata. It doesn't mean it's good or bad, right? We're not telling you the repo is safe and that the maintainer isn't putting malware and Bitcoin miners in it. What we're trying to do is build up a supply chain of metadata that we can trust and prove that if something came from this repo, it actually did come from that repo. The repo might still have malware in it. That's a separate problem. It might still have a whole bunch of known vulnerabilities, but at least we know it came from that repo. And then we can start to do the same for maintainers and see who the maintainers are. And if there's only one, then we know that's a problem. But a lot of the data today, you just can't trust the data at all to even go and start making a lot of these informed decisions. So that's where I'm starting, both because I think it makes it harder to attack supply chains and because it starts to unlock a lot of these other types of things you can do when you have all of this data.
Going back to Ken Thompson earlier, he installed backdoors to make it easy for him to show that securities were bad. Can't we just admit that there's always going to be Bitcoin miners working in my dependency tree and just install a backdoor to have the Bitcoin go to me instead of them? Surely that's the better fix, right? Just admit it's going to be bad. Make sure the badness goes to you.
Yeah, attack the attackers. That's a good one. No, I think in a lot of ways, the Bitcoin mining and DOO mining and stuff has been, a nice occurrence and a boon in a lot of ways, right? It's disruptive way I can think of an attacker, making a profit off of getting into somebody's infrastructure, right? Compared to the ransomware attacks we've seen over the last couple of weeks, I think most people would take Bitcoin mining, which is just burning CPU, over losing your customer data or losing access to your service. So in a lot of ways, it's nice that this has happened a little bit. Nobody wants to have coin miners running on their infrastructure. And I think GitHub even had to go and do a whole bunch of work to reduce quotas and everything. And the end benefit was CI was harder to use for open source projects, but because people were abusing it with coin mining. So it goes both ways. I think we're going to keep seeing it as long as it's that easy to get arbitrary code execution in people's projects. But I'll take that over a bunch of the other attacks we've seen any day.
Yeah, I think what's scary is that this isn't really fun and games at the end of the day. Like, it's interesting, but people have died because people have hacked hospitals and demanded ransomware. People have not gotten their chemo because they couldn't get into their systems and didn't know their data. And that's really hard to deal with, right? That's super stark. I'm glad people like you are out there doing this work. How do you stay sane? I mean, your hair is pretty messy, but like, how do you deal with that pressure?
Pressure, really? If I don't do anything, then it stays this bad. It's not getting worse. I'm trying to avoid getting in one of those Nebraska scenarios, holding everything up myself. And I see it as, a whole bunch of small wins we can make every day. So it's kind of nice and motivating that way.
I like that answer. Awesome.
One thing I want to know is what repository or what package manager keeps you up at night? You got so many different package managers that's touching pretty much every developer in some way or another. Are there any out there that are like, oh, wow, these need attention, or are they getting the attention they need?
I think PyPy was, I don't want to say it's in a bad state, right? I don't want to blame people. It was something that people didn't realize needed funding over the last year. And I think, through a bunch of different grants and stuff they've gotten, it's gotten into a much better shape, which is great. I think from a package manager perspective, I think I start to worry more about the kind of OS and distro level ones, the things like apt-get, the things like Yum, DNF, and the Fedora ecosystem. Most of those were built for actual machines that would install things and update things and pin things and downgrade things. And they're built in a different era where the keys were distributed in a different way and all this stuff. So they don't support a lot of the declarative installation mechanisms like you can start to do now in pip and npm, where you can install fixed versions of things. You lose a lot of metadata when you're doing it in those old ways, and they're at the very bottom of most people's container images. So an attack in one of those, I think, would be really hard to spot, really hard to recover from, and pretty wide-reaching. Thankfully, they're run by professionals in most cases and people that take security really seriously, but those are the ones that I do really worry about the most.
Do you think using something along the lines of Sigstore or upgrading their infrastructure or their backend to support today's standards of security is something that could be easy to implement, or is it just they're going to have to think from the ground up again?
I hope so. Sigstore is only a couple months old at this point. We are seeing people start to use it kind of in parallel with package managers, like their maintainers of Debian packages that are signing individual packages with some of our tools. I hope we get to a point where people can start to use it for those lower level package managers. They've spent years working on their infrastructure, which is great, and I hope to make it easy so people don't have to do that again for the next generation of package managers and everything.
So we are running up on time. So before we head out, and I just want to say thank you so much, but you have so much good advice and you're very eloquent. I think not only in how you talk, but also in how you write. Where can people find you on the internet?
Yeah, my Medium page is where most of the stuff I write ends up, DLORENC.medium.com. I think should get you all of that stuff.
And if you had a couple of tips for anyone out there who's using cloud providers at the moment for working for open source projects, what would you say is the easiest way to get their security up a tiny bit?
Turn on Dependabot, start updating your dependencies as quickly as possible. That one's kind of controversial. I'm going to say it anyway. I think, update as frequently as possible. Take the small version bumps when you can, because it means when there is a CVE found later, it's way easier to update your way out of it than dealing with, a year or two's worth of backlog of updating things. That goes against that if it's not broken, don't fix it philosophy, which I get. I think when you weigh it out, though, just take the updates and roll with them as they come. That's a big one. And then just pay attention to what's in your dependency tree. Write it down somehow. Every language, every package manager is a little bit different, but use full lock files. Don't let left pads break you, that kind of thing. Vendor stuff where you can, use proxies if you have to, depending on the ecosystem. But insulate yourself as much as possible while taking the updates as fast as possible.
Thank you so much. Dan, it's been a real pleasure to talk to you. I really appreciate you coming on the podcast. Everyone, that was Dan Lorenc. If you have any questions for him, he has a Medium article and he may respond to comments. If not, well, I don't know what to do. Maybe he has a Twitter.
Yeah, Twitter works too. LORENC_Dan.
Got it. All right. Thanks.
Thanks.